60-second adventures in astronomy. Number 1. The Big Bang. Just how big was the Big Bang? The idea that the universe is expanding as the result of a single explosion wasn't always universally popular. In fact, the term Big Bang was coined in 1949 by astronomer Fred Hoyle as a way of sarcastically dismissing it. But thanks to Edwin Hubble, we now know our observable universe is expanding. And extrapolating backwards, we can tell that 13.7 billion years ago, it was all compacted into one superdense ball. And this singularity expanded and cooled to become everything in the universe that we see around us. So though the Big Bang involved everything in existence, its beginnings were really quite small. And after measuring the background radiation in the universe, astronomers have worked out that the Big Bang was only around 120 decibels, about the volume of an average rock concert. So while the Big Bang still has a lot to teach us about the universe, we do know, at least to start with, it wasn't particularly big. And it wasn't much of a bang either. "60-second adventures in astronomy. Number 2. Supernovae. One of the most mind-blowing events in the universe is the explosion of a star. In 1054 CE, Chinese astronomers spotted one so bright they could see it in daylight. Today, you can still see a cloud of gas and dust from the same explosion, and because a drawing of it looked like a crab, it was called the Crab Nebula. Much like a supercharged lighthouse, the center of the star, now a neutron star, spins 30 times a second, and sends out a beam of radiation. Several thousand of these have been discovered, each about 20 kilometers across, but with a mass similar to the Sun. If we could imagine a cup full of neutron star matter, it would weigh 100 billion tons. But supernovae are more than just impressive bangs. Life-forming elements like carbon and oxygen were created inside stars. And the explosion of the star creates even more elements, like gold and platinum, to create generations of stars and planets, and a variety of attractive ornaments. So in a way, everything is made of stardust. But luckily, it's not all quite as dense as a neutron star. "60-second adventures in astronomy. Number 3. Exoplanets. Like fussy holidaymakers looking for a home from home, astronomers are fascinated by finding planets similar to Earth beyond our solar system. But planets outside our solar system, known as exoplanets, are difficult to spot because they get lost in the glare from the star they orbit, like a mosquito flying around a street lamp. So how do you see something that's effectively invisible? Observing the changing appearance of some stars, astronomers found that an exoplanet could be detected by measuring the effect of its gravitational pull on the star it orbits. Some can also be detected if they pass in front of their star, causing its light to dim slightly, like a wink. You can even work out the planet's mass and size from the amount of the star's wobble and the depth of its wink, which gives us a pretty good idea of what it's made of. Some exoplanets may even contain water because they orbit their stars in the Goldilocks zone. Any further away they'd be too cold, any closer too hot. And although hundreds of exoplanets have been discovered, astronomers haven't yet found one that's just like the Earth. Who needs a second home anyway? "60-second adventures in astronomy. Number 4. A day on Mercury. No two planets act exactly the same, whether it's Jupiter spinning in only 10 hours, Venus spinning backwards, or Uranus tilting to one side. But Mercury is particularly strange. It takes nearly 59 Earth days to rotate, which might make for a pretty long day, but at least you'd have time to get things done. But while the days are long on Mercury, the years are relatively short. It travels round the Sun in just 88 Earth days. Now, until 1965, we thought Mercury span exactly once per orbit, which would mean that one side of it was always facing the Sun. If it spanned twice every orbit, its day would be the same length as its year, which would at least make calendars nice and simple. But it actually spins 3 times for every 2 orbits, which means each Mercury day lasts for 2 Mercury years. So while you might get a bit bored waiting for the evening, at least you'd be able to celebrate your birthday twice a day, even if you had to share it with everyone else. "60-second adventures in astronomy. Number 5, the rotating moon. Whenever you look at the moon from Earth, it always looks similar. Different parts are illuminated at different times, but oddly we always see the same features. The moon never turns its back on us, much like the rules of etiquette when you visit the Queen. So does this mean the moon doesn't rotate? Well, no, because then, as it orbited us, we would see first its front, then its left side, and then its rear. What actually happens is that the moon rotates exactly once every orbit, which takes a bit less than a month. So, though you'd see it spinning from an outside perspective, from the Earth we always see the same side. In fact, we didn't get a proper view of the far side of the moon until 1959, thanks to a Soviet space probe. The moon used to spin a lot faster, but over millions of years the gravitational pull or tidal force from the Earth has slowed the moon down. The same thing has happened to most moons of large planets. But it doesn't work both ways, because while the moon is spinning once every orbit, the Earth is rotating about 30 times faster. So from a vantage point on the moon, you'd get to see us from all sides, if you stuck around long enough. "60-second adventures in astronomy. Number 6, life on Mars. For centuries, writers, astronomers and David Bowie have been asking, is there life on Mars? The idea that we're alone in the universe seems incredible, so people have dreamed up all types of alien. We know there aren't any bug-eyed monsters on Mars, but it does have a lot of places where microbes could live. This may inspire a low-budget movie, but crucially, if life on Mars started independently from life on Earth, then it's much more likely that it could also start in other places in the universe. But over billions of years spent with asteroids crashing into them, Earth and Mars have exchanged more pieces of rock than geologists at Christmas. And those rocks could carry microbes from one to the other, meaning any life on Mars could have come from Earth in the first place. So it would tell us nothing about the likelihood of life originating on the planets of other stars. Though it would pose another question. Did life on Mars come from Earth, or did life on Earth originally come from Mars? In which case, Martians could be a lot closer to home than we thought. "60-second adventures in astronomy. Number 7, event horizons. Just what is the point of no return? Karl Schwarzschild was a German physicist who not only served in the First World War, but at the same time managed to work out the exact distance from the centre of a black hole to the point where gravity becomes so strong that even light can't escape. This is the point of no return, also known as the event horizon, because much like the normal horizon, beyond it nothing can be seen. But it's not just black holes that have event horizons. The expansion of the universe is accelerating, meaning the space between distant galaxies and us is expanding so quickly that their light can't travel fast enough ever to reach us. So the whole universe is a bit like an inside-out black hole. And as it carries on expanding, fewer and fewer galaxies will be observable to us as they pass to the other side of the event horizon. And when they're lost from view, that's it. They're not coming back. That's the point of no return. And the whole universe will eventually just